I'm D++, and I'm going to be debuting a brand new project that I made today. This is the world premiere of the Bitcoin Ball RBF tournament, which is an interactive video game whereby we're going to split the room into two separate teams and compete against each other for Bitcoin. So while you're thinking of your team names and strategizing who you want on your team, I'm going to talk first about how the game works and what it's doing under the hood. So before we play the game, this is a little bit what it looks like. It's a simple kind of soccer-style game of getting the ball, or the UTXO, into the goal. But what is a UTXO? How many of you know what a UTXO is? And how many of you don't? There's no wrong answers, by the way. There's no shame in not knowing something, because that's how we learn. So, how many of you are developers? And how many of you are not developers? Okay, and how many of you are not technical at all? And there's no wrong answers. Okay, of the developers, how many of you have worked on interacting programmatically with Bitcoin, either on the protocol side or the application side? And how many of you want to interact with Bitcoin programmatically? That's kind of why you're here. Awesome. So I wasn't really sure how technically in-depth the audience was going to be today. So I was going to go through some of how transactions work, since my game is programmatically building and broadcasting transactions in JavaScript. So how many of you are familiar with the guts of how Bitcoin transactions work? And how many of you kind of aren't? No wrong answers. Okay. So let's just talk briefly, and forgive me if this is something that you already know, but let's just talk briefly about how transactions work. So every Bitcoin transaction spends Bitcoin from one or more sources or one or more inputs, okay? And those inputs are like stacks or little piles of Bitcoin. Bitcoin uses what's called a UTXO model, meaning when I spend Bitcoin, I'm spending what are called UTXOs. Now, what does UTXO stand for? Unspent transaction output. It's a very verbose way of saying Bitcoin that I haven't yet spent because it's spendable. After I spend it, it's no longer mine. So it's my Bitcoin is my UTXO. Now, what's interesting about the UTXO model, as opposed to, say, an account model like my bank uses, is I have to spend the entire UTXO all in one go. If I have a $100 bill in my pocket and I spend that at a store, I can't rip off a little piece of the $100 bill and give it to the merchant and say, here, you're getting a third of $100. No, they want the whole amount. And if my item is less than $100, then what happens?
Change.
I get change. So in this case, I'm sending the whole amount, which is 46 Bitcoin.
Wow.
And I'm probably only paying, we don't actually know which output is change and which output is the recipient, but I would guess that the recipient is only getting a tiny little amount of Bitcoin and the rest is coming back to me as change. So I'm essentially spending a $1 million UTXO and getting it all back to myself in change because Bitcoin uses a UTXO model. Now, this is not how the money in my bank account works. In my bank account, I have one balance, and if I pay someone from my credit card or my debit card, the amount just gets debited from the total, right? Now, the difference between the inputs and the outputs of a transaction is the fee. Okay, now the fee doesn't have an address where it's going to. We just know that it's going to where? The miners are going to get the fee. So I don't specify actually anything in the transaction at all to the fee or where it's going, but Bitcoin knows that the difference between the inputs and outputs is the fee. Now, how many of you have built Bitcoin wallets before? Nice. So for those of you that have built wallets, you want to be really careful when you're coding these wallets, right? Because if you make a mistake and you don't calculate the outputs correctly, then what happens? You burn Bitcoin, it goes to the miners, so it's not going to nowhere, but you want to make sure that the outputs are of the correct amount, such that you don't burn Bitcoin unnecessarily to the miners. Now, the miners are going to want some kind of fee. We're currently in a low fee environment, so what does that mean? Do we pay a fee based on the amount of our transaction, which in this case is 46 Bitcoin? Do we pay like a percentage of the total amount?
No.
Who thinks we do? No one. Okay, that's not how Bitcoin works. How do we calculate the fee? Well, it's not based on how much Bitcoin we're sending. It's based on the size of the transaction in bytes, or since SegWit, in virtual bytes, which are funny and outside of the scope of today's talk. V-bytes, exactly. So with one input and two outputs, one of which is likely the change that's coming back to me, I have a transaction of how many V-bytes? Around 160 something V-bytes. So I'm going to pay Satoshis per V-byte. Now, what is the kind of going rate for Bitcoin transactions right now in a low fee environment? It's around 1 sat per V-byte. How many of you have been around long enough to have seen a high fee environment in Bitcoin? So the 1 sat per V-byte isn't something that we've always enjoyed, and it's not something that we can expect to enjoy indefinitely, right? But in this case, we can likely get away with spending just 1 sat per V-byte on a transaction. And if there's enough space in a block, the miner will be kind enough to include it. So what happens if we set our transaction to use 1 sat per V-byte, but blocks are filling up and the miners are economically incentivized to include transactions that have higher fees? We've already broadcast our 46 Bitcoin transaction, but it's not getting included in the blockchain. What do?
Replace by fee.
We can use replace by fee. Okay, so what does replace by fee do?
Replaces the fee. So the fee is higher.
We can spend the same 46.54 Bitcoin UTXO, we can spend the same one to either the same or even completely different outputs with a higher fee. And the miners, again, being economically incentivized, will probably want the transaction with the higher fee. Now, how many of you have done this? How many of you have bumped the fee in a transaction? Okay. So there's a couple things that need to happen in order to replace a transaction. One of those things is we have to opt in to replace by fee, or RBF. And we do that how? How do we tell the transaction that we want it to be replaceable?
The sequence number?
There's an end sequence number. So there's a 32-bit number, not just for the entire transaction, but for each input. And we can have more than one input, right, in a transaction. There's a 32-bit number called end sequence for each input. And if any one of those end sequence numbers has signaled to opt in for RBF, then our transaction is replaceable while it's unconfirmed. Right? Because transactions don't immediately get published to the blockchain. They wait in a holding zone before they get published. And where are they waiting? They're waiting in the mempool. Okay, what is the mempool? Well, the mempool is a place in memory on my node where transactions are queuing. But there's no one singular mempool, right? Everyone's node has its own mempool. And how many of you are running a node? Quite a few. I love it. This is definitely the most technical audience that we've had, which is awesome. So we all have a mempool on our node, and miners who are creating candidate blocks also have their own mempools on their nodes. Now the mempool defaults to around, I believe, 300 megabytes, but that's customizable. You can tell your node's mempool to be as big or as small as you'd like. Now, how many of you have been around for long enough to see the entire mempool of your node get full and have transactions actually fall out of the mempool? That has happened in the past, and I'm going to talk about a problem that poses. So we have this end sequence number that we're going to modify in order to opt in to replace by fee, which, by the way, was added to Bitcoin not when Bitcoin was first created, but later in the form of a BIP, or a Bitcoin Improvement Proposal. Now, what BIP specified opt-in replace by fee.
125.
BIP 125. So when I was creating this talk, I actually became an author of BIP 125. Very exciting. I'm now a contributor to the BIPs. I added, I think, the word "the." There's a grammatical error, but hey, my avatar is still on the BIP page, and I'm going to go with it because I'm proud. So the end sequence number is a 32 bits, which we don't technically need 32 bits to signal for RBF. I think 1 bit would have just been fine. The reason why the end sequence number is greater than 1 bit is because it's not only used for RBF. So what else does Bitcoin use end sequence for?
Time locks.
Relative time locks. So with a Bitcoin transaction, we can have either a relative or an absolute time lock. And relative time locks are used all over the place where?
Lightning network.
In Lightning. So relative time locks are very helpful for protecting our commitment transactions in Lightning from getting stolen by our channel partner. And they're also great for opting into RBF. Now, in order to opt into RBF, what does the end sequence number need to be set to?
Lower than FFFFF.
Good one. It has to be less than FFFFFFE. So all Fs we have not allowed for RBF, and FFFFFFFE we have not opted into RBF, which means that, as far as I know, and correct me if I'm wrong, any input that's using a relative time lock is automatically opting in to RBF. So you're going to set your end
Unless
sequence.
your time lock is ridiculous.
Unless your time lock is all Fs. So end sequence must be less than 7 Fs and an E. Any questions so far? This is all pretty basic stuff for all y'all very technical developer kids. Well, feeling good about RBF? Okay, so there's another way to bump transactions that are waiting in the mempool, aside from RBF. And how do we use the alternate method? CPFP. So child pays for parent. So child pays for parent is a little different from RBF. With RBF, the sender of the transaction has to bump the fee. But with child pays for parent, the recipient of the transaction can bump the fee, which is very convenient. So if I receive Bitcoin, let's say from Nadav, because he's answering all of my questions. If I receive Bitcoin from Nadav and his transaction is pending in the mempool, let's say he's being a cheap ass and he only specified 1 sat per VByte, I can spend from those unconfirmed funds to somebody else, and I can include a much, much higher fee in my child transaction, which is a child of Nadav. Now the miners, again, being economically incentivized, are going to want my juicy transaction with my very large fee, meaning they'll include Nadav's cheap-ass transaction only because they want to get to the sats that I have generously allocated to the miners. Now, there's one problem with child pays for parent, and that is if the mempool actually fills up and very, very cheap transactions such as Nadav's are actually falling off the mempool entirely. So if a miner sees my transaction that spends from Nadav's, which has been rejected from the entire mempool, then what are they going to say?
It's invalid.
They don't know about Nadav's transaction. So although they want my juicy fees, they're not going to get it because they're treating our transactions as if they're completely separate, but really we're a family. So it'd be great if the mempool would treat these families of transactions as packages. So thanks to Gloria, who is a recipient of a Brink donation, she's hopefully fixing this for all of us, which right now is not a problem because we're in a low-fee environment, but we want to plan for the future, right? When Bitcoin onboards the next billion users. And in the future, we're definitely going to want package relay, again, which refactors the mempool to treat packages of family transactions as one family unit. So there's a couple things that she's going to have to undertake in this project, which is protection against potential attack vectors, such as denial of service attacks. So is anyone following the development of package relay? Can anyone update us on what Gloria's up to? Any
2
updates?
weeks.
She's going to ship it in 2 weeks. She's going to refactor the entire mempool in 2 weeks. There's a lot of steps to actually deploy package relay, but we hope that hopefully we're in good hands with Brink and Gloria. So basically, I've talked very briefly about how transactions work. They have inputs and outputs. The inputs of transactions stemmed from the previous outputs of the parent transactions. It's a little verbose the way that we define some of these terms. But any questions about this, or is this just very simple? Question over here.
Is there a limit on how many parent-child packages can be?
I think it's 100, but can someone correct me? I was going through the BIP, and I think it's 100. So there are some denial of service concerns that we have with some of these limits, and this can pose some problems also for Lightning if we have one of the parent transactions falling off. Now, one other quick thing that's kind of interesting with child pays for parent is I can bump the fee if I'm the recipient, but I can add additional outputs to a transaction that are smaller kind of dust amounts that can go to other recipients who can then use those outputs to bump my fee. And these have a special name in Bitcoin. What do we call them?
Anchor outputs.
Anchor outputs. We use these in Lightning, and they're pretty cool. So I know you guys want to get to the game, but we had to just do a little bit of big brain Bitcoin thinking first. So now that you understand how child pays for parent works, let's get back to the game. So the way the game works is we have two teams. We're going to split up here momentarily, and we have a UTXO, a Bitcoin ball. We also have two Xbox controllers. So if you get your Bitcoin ball into your goal, my game is going to programmatically build and broadcast a transaction using Bitcoin.js, which is a JS library for Bitcoin, which, by the way, how many of you have used Bitcoin.js? It's pretty cool. I'm going to broadcast a transaction that goes to the recipient of your choice, and I have a list of recipients. They're going to be for donation purposes today, but if you want to include your Bitcoin address, DM me and I'll add you to the list of donors. Now, if your opponent grabs the ball and steals it from you, they're going to broadcast a new transaction that will replace the previous transaction waiting in the mempool with a higher fee. We're going to repeat this process until a block is found. Now, how long does it take a block to be found?
10 minutes.
10-ish minutes, but is it always 10 minutes on the dot? It's a random process. So the game could end at any moment. The game could end in a few seconds after we start, or it could take an hour. It's kind of like a game of musical chairs by which we have really no idea when the game will end. Now that said, there is a minimum threshold by which I must increase the fee on the replacement transaction. And can anybody tell me what that is? Like, could I just RBF the new transaction with a single sat of an additional fee? Yeah, over here.
It has to be the transaction V bytes multiplied with the minimum relay fee has to be added.
That's right.
It's called, relay
That's
fee.
right.
Yeah.
So the size of the transaction in V bytes times the minimum relay fee, which is what currently? 1 sat per V byte, because we're in a low fee environment. So the size of these transactions are pretty small because they only have one input and one output. So they're only about 110 virtual bytes. And if we're using 1 sat per V byte, which is the current minimum relay fee, I only have to increase each transaction's fees by around 110 Satoshis. Okay. Any questions about how new that works? Who's ready to actually play the game? Awesome, yay! Okay, so I'm gonna ask you to please divide yourselves into 2 groups if you wanna just kind of like part the Red Sea and split down the middle. But please be very careful of all these precarious wires everywhere because they're very sensitive, and if we so much as like breathe on them, they're gonna turn off my screen. So we're gonna split into 2 teams, and you're gonna come up with some very creative team names. And once you've come up with some very creative team names, you're going to select the charity or the recipient of your choice. And I programmed in some recipients here. I messaged some different developers and funds who didn't respond to me. So if you ever talk to like Galoy, Bitcoin Beach, or OpenSats, or some other folks, tell them to message me because I want to send them sats. And then we can have fun scoring points. And if you want, after, we can even look at some of the code to see how this builds and broadcasts transactions under the hood. Any more questions before we start? All right, what are those team names and what are those?
We got a question.
Yes, please.
What's the incentive that a miner would have to, when they win a block, to not fill the block even though there are transactions in the
So they wouldn't have any incentive to do that. They would fill the block entirely. So the only reason why you would need to RBF a transaction would be if there were more transactions than the block would allow for. But if the blocks aren't getting full, we can just leave it at 1 sat per rebyte.
It's just when you look at the blockchain, you see non-full blocks. Why would that happen?
Yeah, I'll show you.
So for miners, often, I mean, if you are a miner and you find a nonce that works, even if you didn't maximize on your fees, like that's rare and gives you a ton in the Coinbase transaction, that you mint new coins and you get all of those. So it's still worth it to publish that instead of building a more optimal transaction, because then you're just starting from scratch on the mining. So if you were somehow suboptimally computing your template, or there's some kind of latency where you didn't fill it up but you successfully found a block, then you might as well publish the block.
So it's a mining latency problem.
I don't know. I'd have to ask a miner.
I think that sometimes
Anyone else know?
I think that sometimes there's empty blocks because they haven't been able to validate the previous block, but someone's found it and they want to start looking
I'm not
for a
asking
new
about
block.
empty blocks,
Oh,
I'm
just
asking about
low.
unfilled blocks.
Does that ever happen?
Yeah, definitely.
Like unfilled while the mempool's full?
Yeah.
No.
Yeah, that happens. So, oh, well, if the
mempool
mempool,
the other day and the blocks and
yeah, that can happen because the mempool is filling up while the transactions are being added to a candidate block simultaneously.
right.
So when they find the block, which is a random process, there may be additional transactions that came in kind of around the same time.
Yeah, I think latency is an explanation, but I don't know if it's the
But
explanation.
there's not a single mempool, right? Every node has its own mempool. So if the miners are operating off a node that doesn't have a full mempool, they are going to take whatever transactions they have and publish their block as soon as they can.
Yeah,
you're
so
saying
we're-
that even though my mempool shows that there's plenty of transactions in the
Yes.
mempool, the miner's mempool might be empty.
So playing this game is actually going to give us more of an intimate understanding of how some of this works, because this is my mempool from my house over here, and we're going to see when we broadcast transactions, they're going to show up in my mempool on this other screen. Now my mempool is not the same as the miners' mempools. So just because I see a transaction doesn't mean that it's propagated to them yet. So it is possible that the very last goal might not make it to the miners' mempool, meaning the team that we expect to win might not win. This has happened before, and it's not that there's a problem with the game, it's just this is how Bitcoin works. There's no consensus in the mempool until the transactions are actually added to the block. Kind of shows you why it's important to mine Bitcoin, because otherwise we have no idea who knows about what transactions in what order. Any more questions before we start? Did you guys think of awesome team names? Okay, so the way this is going to work, because we have a bunch of people, is after each goal, you're going to pass the controller off to someone else on your team. And you can use whatever strategy you want, but I would recommend passing it off so that everyone gets a chance. And have you guys thought of your team names and your charities yet?
I think we need a chance to talk about it.
You need a what? All right.
We need several minutes. Jeremy Rubin, of course.
Jeremy Rubin. So if you guys pick Jeremy Rubin, I would recommend the other team picking Michael Fulkson. Because Michael Fulkson, he coined the phrase URSF, user resisted soft fork. So we'd have like a user activated soft fork over here for BIP 119, which is OPSI TV, and then we'd have a user resistant soft fork over here, which would be actually pretty funny if you create your teams based on who's in favor of and not in favor of 119. Just a thought. But you guys, hey, you guys can do it however you want.
That's it, that's
I
our
think we
name.
should go with super test.
Anti-CTV.
The URSF.
Yeah.
I think we have
He's
consensus.
actually going to talk about to RV. What's up?
An R word, a B word, an F word.
We could just be like winning team.
Running,
Remedial
Bitcoin.
Bitcoin friends. I don't know.
Global gem.
What was that R?
Remedial Bitcoin.
Oh, and by the way, we also have a sportscaster. So we're going to be taking the play-by-play with Dusty Damon as our sportscaster, and Super Testnet, who's currently giving a talk. As soon as he's done, who's also a veteran of Bitcoin Ball, both of which they have retired from the game, will be sportscasting.
How about regular Bitcoin fanatics?
I like that. That's good.
You guys are what? The regular Bitcoin fanatics. Regular.
RBF for short.
Okay, and where would you like your sats to go to should you win?
Super testnet? Super testnet.
Aww. How kind, and he's not even here, so that is precious.
I feel like that's gonna make him a biased sportscaster.
So
They should do Dusty.
Super doesn't actually care about winning. It's funny. Like when he had his sats going to him, he didn't really seem, it didn't seem to change his game. And have you guys thought of your team name yet? Y'all are the blue team. So the red team's gonna be on this side, the blue team's gonna be on this side.
Let's go with blue team.
You wanna be called the blue team?
Very original.
We'll be the red team.
All right, and where would you like your sats to go?
Yeah. Base 58.
Base 58? Okay.
Ooh.
All right, and your team is the blue team?
The red team.
Okay, so why do we call the red team? It's gonna confuse me.
Red team, you know.
That's so good.
Okay. All right, so wait, no, that's regular Bitcoin fanatics, which is RBF for short. Y'all are going to Super Testnet. Red team is going to base 58. So this has a wallet inside of the JavaScript program, so it's going to ask for the index of the money. All right.
Oh boy.
This is throwing me off that the blue is red. So all right, I'm going to pass off the controllers. And then we're going to do a 1, 2, 3, go. And when the first ball makes its way to the goal, we're going to see it here in the mempool. So who would like to go first?
What are the controls?
So I vote him.
Anyone want to? All right.
All right, you guys better step up.
Go for it.
All right, we're gonna count off.
What are the controls here?
You'll figure it out.
That's why we let you go first.
All right, we're gonna count off. 1, 2, 3, go.
Go!
Fake out
Friction
red.
is high.
Oh, I can't see
Yeah,
it.
there's a lot of red.
That's a strap. Oh, nice. Oh.
Go ahead.
Oh, there's like feedback.
Try to put it in red, right?
Go red team.
Everyone's cheering for us.
So what they want to do here is get a little big.
Let's go. Come on.
You got the Bitcoin soundtrack? We're stuck here.
How do
How do we get out of this corner?
You can build up speed.
Oh, this is fun.
We need to adjust sensitivity.
You gain velocity if it's in a feedback loop. Oh. So if you're already winning, doing a transaction pin in the corner makes sense, but nobody's winning yet, so. There goes Defense on it.
No pressure, no pressure.
No.
It's feeling no chance.
Oh no, oh no.
Scoring on yourself is also an option. I feel like both teams pick their best players to go first.
Other super! Our sportscaster!
Super's nice. Yeah,
I'm still alive it.
Got it. Got this.
This is deceitfully hard.
Team RBF. So one of the things you missed, thanks for coming, Super, is that you are actually the receiver of the red team, not the red.
What's the hitbox on this thing?
Where's the shoot button?
So interestingly, since it hasn't been a goal yet,
So what I'm under
the
control.
10-minute timer hasn't started.
Just the joystick.
So you guys can switch off.
Like the left one.
So you'll see here in the mempool, this is from my house. It's running on Tor, so forgive me if it's slow.
All right, so now the transaction in the mempool.
Go.
We got about 10 minutes before it gets confirmed. So
No.
Blue team. Red team. Blue team. Red team.
Nice.
Wait, did you guys pass your controller?
Yeah.
Yeah.
I think so.
Okay.
Oh!
Yeah.
Nice.
Well, Thomas, it looks like the blue team is trying to regain control of this. It's definitely in their court at this point.
They're trying real hard, Super.
Rob, you do money.
It looks like they're struggling with staying consistent. And an upset.
There has been.
Yeah, lethal helps for sure.
Yeah, so one of those strategies.
Initiative. No worries.
Take over, tend to do better. But if they're, red team almost got it in there. Red team, the actual red team, not the red team.
The regular Bitcoin fanatics are the ones who I happen to be rooting for, of course.
Yeah, there's always going to be a bias there. I think we're calling them the RBF team now.
Yes.
And their main goal here is to actually get the ball in the goal to perform an RBF.
Philbert, what do you think are the most important things to learn when you're trying to play Bitcoin ball?
The most important thing is trying to go straight. Most people can't seem to do it. Oh, we got a transaction pin in the corner.
I had to learn in my years of playing this game that just came out today.
Well, there's a confusion about which team you're on.
You know, so we haven't played this a long time. You know, I know we've retired as veterans in the game. Yeah, it really does give us perspective, though.
There's certain, one of the lessons I think should be imparted to the next generation of players. Sometimes you gotta walk the walk, and sometimes you just gotta RBF the UTXO.
That's very true. It's very true. And the key to RBFing well is good solid thumbs. You know, which I think is part of what we had to retire, right? Because without thumb guards, you know, those thumbs will wear out.
It is a real contact sport when you consider the smart contract that's involved. So, that didn't work.
So it looks like red has control of the ball over here. It's sitting on that side of the court. Oh, as I say that, blue takes it back.
Let's see if it works.
Red team. The red team with color blue is scored again.
Shoot, I got
Who are our next players? So you analyze these current players physically. Do they look like good FIFA players to you?
I have not yet seen the players. Is that Asher? Is Asher one of the players?
No, Asher.
I was.
I haven't seen Asher.
Oh, hi Asher. There you
I
go.
was up first.
Good defense, Red.
Yeah.
Regular Bitcoin fanatics, I should say.
Now, one of the things Blue Team may not realize here is that they already have the donation. So if they score again, all they're going to do is actually reduce their donation.
Right. They're going to RBF it.
But they can't help it, right? So okay.
They're increasing their donation to the miners.
Poor money.
So what you're saying is,
Oh, that was a nice little
order.
Yeah.
Miners, don't fail me now. Come on.
Curve it like code
Lock this in.
So I think it's one of those strategies you learn as you get more experience. Is once you're ahead, you really want to try to do a transaction pin so no one else can get it in. So that's really the red's interest right now. And it looks like maybe he's figuring it out. Oh, but blue got it out.
maintaining the status of stuck in the corner. Normally you don't want your transactions to get stuck, but when it's coming to you, it's not a bad strategy.
It's true. That's true, Tim.
Oh!
Wait. Oh, but you know, Red did the classic mistake there of not going straight. And it's one of those things you got to keep telling the players, but no matter how many times you tell them, they don't seem to do it.
We're saving on
A lot of the
fees.
strategies are still being developed, and as the rules of the game continue to change, some more techniques may be developed still.
We need to maybe a curveball one day.
Yeah, I think I would love to see some additional strategies developed.
I think that's really the key. If we look over on the right here, we can see the curveball.
Anyone else?
So our RBN is the RBN.
It's red or blue?
Rounding blue.
Oh, it's blue.
Wide open.
It's been on here. So if we look at the unconfirmed transactions in mempool, I think it's going to be about approximately 10 minutes till we see that get confirmed.
Typically, I've never seen it say anything else, which may indicate.
Oh!
How does this clock work when it's always 10 minutes till the next quarter?
There might be a bug in the system, but the current ETA, you can see the second line there is about 10 minutes.
Yeah, isn't it like
Yeah.
infinite if we keep scoring goals?
So if you were able to slow down the miners by RBFing, you would, one, be a hero, but also break Bitcoin. So we don't do that.
It's one transaction that's being replaced, and so if the amount of goals you keep scoring does not affect when the transaction is actually going to be mined. Only one of these transactions is actually going to end up being mined.
And that's really what an RBF pro is going to know, right? And that's the kind of it takes that we can bring to the table here.
You see the new Marvel film?
I haven't, but I did see Top Gun. You know, this game kind of brings back some of the same action and excitement that I saw in that movie.
Yeah, I think that what Top Gun did for naval recruiting, this game is going to do for Bitcoin development recruiting.
Probably. Oh, so it looks like Red is getting smart. He's not scoring a goal. Instead, he's just keeping the ball away.
He's learned the technique of
Oh,
transaction.
but it failed on him now. Now it's over on his side. He's got defense.
Hard to play this in the back of the room.
No excuses.
Yeah, the best players never make excuses. They always play themselves. If their controller fails, they still play themselves.
Oh!
Try to reinforce that.
So it looks like Will's figuring out how to get out of the transaction pin corner. And that's really an important step.
Oh!
The takeaway.
We got this.
So I kind of where's the shot clock?
Get it.
Only one of them did they do the same thing.
So I wonder if the ref will notice the blue team did not pass the controller.
Oh, where do I pass it?
He's going to take over.
We have it, so what do I do?
Or strategy. You gotta wonder how long this game is gonna go on.
It's, well, it still says 10 minutes. So,
You're the red one.
Yeah, I think it'll be approximately like 10 minutes from now. Oh, we got another. Blue's got a goal.
Ah, the name
Who's
confuses
that?
us.
Someone plays FIFA over here.
Oh, here we go.
But I need to give the controller on top.
Defense.
Because it's one person.
Yeah, it is interesting in this sport, right? You really gotta watch out for the refs, but there actually are no rules. Oh, Blue's taking a breakaway. So interesting, we saw Red in last round using the transaction pinning technique, but we're not seeing the Red team do that.
they're experimenting with new strategies. They also just had a player change. Mid-game player changes can result in...
Yeah, you wonder if their bench sitters are going to be able to add to the game or take away when they come in. This is the kind of game I think if you have a lot of Bitcoin programming experience, can really give you an edge in getting the Bitcoin ball over.
I heard that there was a time when you used child pays per parent to prevent them from doing an RBF.
Yeah, I think that was one of the early versions of the game, but it caused a lot of controversy, you know, with the minors and children. We don't want to keep that involved in the game.
Yeah.
You know, fun fact, the word nonce in British English actually means pedophile.
So I'm surprised you're so familiar with the term.
So you ever give a category talk to like British native
Oh, Mike, this is not good.
Okay, I feel like the blue team has got backwards controls going. Oh, they scored themselves.
Are we, is there anybody else?
We're recycling back.
Oh,
Who did?
Yes.
How many minutes has it been?
Has someone,
so the ETA is about 10 minutes. For the,
How long have we been going?
Oh god, that's dangerous.
well.
Nice defense, right?
feels kind of blurry.
Ordinarily, miners are faster than this.
They need a difficult problem.
Yeah, whatever you
Crushed it.
Whenever you
Do it
wait
again.
for a block, it always takes an hour.
Yeah, that's 100% true. Whenever I'm like,
The watch clock never minds.
The average like skill is going up here.
The miners may be watching the game. Turned off their hashing equipment.
Oh.
Nice save.
hash rates down, difficulties up.
Red's trying to do a transaction pin, it didn't quite work. Oh, little defense. That's Blue's going the wrong way now. Red's go. What's gonna happen?
Oh!
Bouncing off Blue to get in for the RBF.
Some video game experience there.
And I feel like they haven't really learned yet that when you're ahead, you don't need to score a goal.
This game doesn't have a halftime, but we do have a happening.
So anyway, I was saying about nonces. It's an important thing to keep in consideration here. We're talking to British speakers about photography, because they're going to hear something different and start talking about chosen nonces and such.
So you want to make sure your nonces are definitely pre-randomly generated.
Yeah, you want a new nonce every time. That's key. Alright, so Blues playing defense, but if I were Blues coach, I would say go on the offense, because they're currently losing. And the score doesn't matter. All that matters is who scored last.
We have a new blue player, and the blue player was experimenting with how to undo a pin, transaction pin.
Oh, did he learn how to pin it?
He managed it after a number of attempts.
Without package relay, very impressive. Red's trying to initiate a pin, but it wasn't the best pin, I don't think. I think that Red's really owning the game here. I wonder if
it's red team.
You gotta wonder if Red's trying to score or if he's just playing with Blue now.
For those who are watching at home, the teams are called regular big
Does anyone know
red
defense?
and red team, which is the blue color.
I feel like we should decide if we're gonna call the red team Blue team or red team.
I think we should call the red team RBF.
Alright, it looks like, I feel like this guy's played FIFA before, so this is gonna be a huge advantage. But you do gotta wonder if he stretched his thumbs beforehand? No!
Oh no.
I call it.
You call it, and when you call it, you call it.
So, if you think about it, the regular big win fanatics score their most goals, but they're currently losing.
They're also reducing the number of stats I obtain.
That really seems like the point of the game, right? Like, see how much.
What's the record? Most RBFs.
We may have reached that record.
The game's never gone on this long.
The miners are watching. They want as many fees as possible.
They're incentivized to pay for higher fees.
20 minutes since the last block.
Foundry, you guys are in here, right? You guys got on the stick?
It's a good point. It's been 20 minutes since the last block, and the next one's coming in about 10 minutes.
That is true.
2 weeks. 2 weeks away.
Come on, Nadal, let's go. Be a hero.
I believe.
We want to give Super Testnet all that money.
Yes, we do. That is the goal.
It's the right goal.
Oh.
Good job, Red. I mean,
You can knock it in yourself and reset it in the middle.
Strategy.
I feel like the players with glasses seem to be doing better. I wonder if that's an unfair advantage.
There you go.
No, that's not true. That's not true. I lost there.
Yep, there it is. That's
So this is a visual pin where both parties put the transaction together. Now it's not in Red's interest, but you gotta wonder what their plan
this
is
technique
there.
originated in the Star Wars films.
That's true. Yeah, so I think like one of the main strategies I would focus on, if I were Team Red here, is trying to go straight with the ball. And you see them kind of like going to the ball as if they're going to go straight, then they bump it sideways and go around it sometimes. They're generally the things you want to avoid.
You're in the zone, in the red zone.
I mean, the other keys to the game you want to see is good defense.
This does give a whole new meaning to the term coin control.
You really want solid coin control, right? I think you got to know like where your RBFs are to know what kind of coin control you want to do. towards this goal, I see that's probably not the right move. I'd recommend pushing it away from the goal.
You give a lot of advice, don't you, my friend Filbert?
Well, I'm just trying to share my expertise with everybody.
No mercy, right away. Another goal. Don't touch it.
That is
Who wants it?
Go ahead. I'm not losing.
I'm good.
Like, keep away.
So the game going on this line, you gotta wonder when the next block's coming in.
Seriously.
About 10 minutes.
Yeah, I think it'll probably be like probably about 10 minutes.
We're witnessing the death of Bitcoin right
What were you doing when Bitcoin died?
Red got it again.
Who wants to do it?
I'm gonna try.
There are circumstances where a miner mines a block, but it hasn't propagated to the mempool that the game is watching yet. And if that happens, it's possible for a goal to be scored, but it doesn't get into the block.
No.
The block will
Nice.
That's true. That's true. And I wonder at this point that everybody's played, if teams have learned yet there's no rules, and they can pick their FIFA players to take over.
What are transaction fees this time? So maybe that's why it hasn't. Maybe there are blocks coming in left and right, but it's just like.
So I think currently the fee is up to 3,240 cents.
Sort of hefty fee for the miners.
Yeah, let's see if they can get it higher. Do you think that's enough to get the next block?
I wonder. Can someone check what the estimated next block fee is? 10. It's 10?
How many bytes?
We're gonna be here a while then.
It's like the Wi-Fi is down. It's not even broadcast.
This is testnet.
Is this on testnet?
No.
Oh, okay. Red scored again on themselves.
Okay,
Good job.
The fees are actually down. I feel like Red is starting to pull ahead here.
Red is one of the techniques that we pioneered as ancient members of the gaming community.
I remember that from weeks ago.
Last block.
Oh, go! Who's almost got it? Oh, figured it out.
Keep going.
Keep going, keep going.
Keep going.
So base 58 gets the donation if they win. If red team wins, team red. Team red.
Go.
So let's see, it's been about 25 minutes since the last block.
When do you think the next is coming?
I think it'll probably be about 10 minutes for the next block. Yeah, we can see here the ETA is 10 minutes. And then pull up space grid showing
I
us.
believe you said that 15 minutes ago.
I think it was true then too.
Funny how random times work.
That's stuff an element you got to consider when you're playing. It's just about being the last one in. So if you have intel of when the next block's going to happen, you can just let that win to the last minute and then score.
Really, the ultimate strategy would be first to get the UTXO into your goal, and then mine a block.
Yeah, like you have access to a powerful mining rig where you can just do that.
Start working on nonces at that moment, and you've got a key advantage.
Yeah, actually, you know, Super, since it's going to you could do a CFP and pin that transaction with your phone.
Yeah, I just don't want to take away from the joy of the game.
Well, that's good of you.
What would happen if you paid a miner out of band to take the RBF history up until one of the red wins?
Then you better hope that the miner gets the next block.
I think what you call that is cheating.
Does someone else want this?
Okay, the red team color blue is ahead again.
Go. One nice thing about the game taking 25 minutes is that everyone gets to play. We've got a room full of 60 people, and I think 2/3 of them have played now.
Remember back in games, like we had games that would last like 2 minutes. Having one of these long games really puts more of an endurance question for players.
We thought about putting this game on lightning, but it would be over before it started.
Yeah, so games like this that go on this long, the thumb endurance really starts being a factor.
Well, not when you have 60 players.
It's true. That gives you what, 120 thumbs?
Only need some spares.
Give or take.
What is the average energy output of a thumb?
I think it's
On
it's
average,
a single
less.
lot, but we're in a game like this, we don't.
We're in 6-7 matches per day.
I can't I'm in the corner. Yesterday saying he was.
So the funny thing about transaction pinning is that both players have to agree to it, and they seem to do it for a little while there. Oh! Yeah, way wet. But you can't notice that these rookies are getting better and better.
The upward diagonal strategy that you employ there is one of the killer techniques in this game. It allows you to use the Pythagorean theorem.
That's true. Using triangles, right angle triangles is really.
Oh no!
I know that.
Wait, no, we won!
Which one got in?
So here's an interesting
I'm really confused.
feature of
Wait.
the mempool. An interesting feature of Bitcoin is, and this needs to be calibrated, so I don't know what happened here,
This
but
might be upset.
the most recent goal, as you saw, came in right before that block was found. So the team we expected to win
Didn't.
didn't.
It's time in the mempool, not timing the
What do y'all grab a minor without having rules?
So if you really
but it didn't get into the
Yeah. So if you really want to win this game, you want to get the goal, and then you want to prevent someone from getting a goal after that.
Oh, right.
Good offense and then good defense. Got it.
Right.
The
Because
insights into the world of sports that you can gain from adding Bitcoin to it is just incredible.
right, because the other team they got a goal just right at the same time the block was found. So this is how it works. And what I like about this game is it really shows you the sort of randomness of the mempool, of the transactions, the fact that there's no consensus in the mempool, the transaction we thought we were going to see, we didn't see. The cool thing about Bitcoin is that proof of work brings us all into consensus. So any questions or comments?
Does the transaction say overpaid 34x?
Can you scroll up and see what we?
Can anyone
Should have
calibrate-
used
Can anyone figure out how to calibrate? Okay, so
The real
let's
winner of
see.
this game is the miner that mined the block.
Page 35.
Awesome. So we can do another round if anyone wants to keep playing. Other than that, we could also look at the code and see what it's doing. What would you guys prefer to do? The code.
What was the other option?
Play another round.
I think that game was very long.
Should we bring Super and Dusty out of retirement for
Super vs. Dusty.
Okay, so I want to also
His
shout
skills are
out.
dusty, but mine are super.
I want to also shout out Super because I used some of his libraries in the code. So
Welcome.
thanks for that, Super.
It's unfair for him to play. His
So
code's literally-
Super did a project called Stealth Addresses, and I took some of his libraries to build and broadcast the transaction. So the way it works is I have a private key, which is just a seed phrase, a 12 or 24 word seed phrase, which I have saved in my JavaScript file. Not a good idea for any kind of wallet that has a large amount. And how many of you are familiar with HD wallets? So with HD wallets, you have not just one public-private key pair, you have a lot of them, right? And the way that you organize them is using what are called derivation paths. So how many of you are familiar with derivation paths? So every time I generate a new address, that gives me a new pub-private key pair, right? So I can send Bitcoin to the pub key, and then I can unlock it or spend from it using a private key. So we are going to derive the private key from the derivation path. Now I have a funny derivation path here, but
You also have funny seed words.
don't look at my private keys. I have kind of a funny derivation path here because I'm using a custom account, but we will show you how this works. So the way that it works is we build a transaction. Now, remember we looked at UTXOs about how Bitcoin that has not yet been spent is called a UTXO. Now, how many of you have built a transaction manually? Okay, so when you build a transaction manually, do you put the Bitcoin address as the input to the transaction?
No.
No. Why not? Well, in any one given Bitcoin address, you could have more than one UTXO, right? So you want to specify the UTXO that you're spending from. So how can I specify what UTXO I'm spending from?
Use the TXID.
Right, so I look at the transaction that Bitcoin came to me in. I have the TXID. But there can be multiple outputs in a transaction, so how do I know which one I want?
Use the V out.
There's a V out, which is the index of the output. So starting counting at 0, 1, 2, 3, 4, etc.
And together they make an output.
You're going to get an out point, and the out point is going to be the TXID and the index. So what we're going to look at here is I'm going to look at the address from which I received the Bitcoin, but that's not enough. I need the TXID and the output index. So I'm going to do a couple of things to give me the ability to sign the UTXO at that particular address. So I'm going to need to derive a key here. So I'm doing some key derivation stuff. And then I'm also going to want to look for the TXID and the output. So what I'm doing here is I'm pinging an API. And in this case, I'm just asking Blockstream. So I'm trusting Blockstream is going to be honest and tell me about my transaction. There's no reason probably why they wouldn't. But if I wanted more privacy or if I wanted more security, instead of just pinging Blockstream a bunch of times, I could actually interact with my own node, which I'm not doing because I'm using Bitcoin.js here. Okay, so I'm going to get the ID, which is the same as the transaction ID or the transaction hash, kind of same thing. And I'm going to get the output index, and then I'm going to prepare it for signing. So if I go down here.
Can we make the font a little bigger?
Oh yeah. So this is the magic with which we use to construct that transaction. So I have, remember how transactions have inputs and outputs? Well, I can programmatically add as many inputs or outputs as I want. Now, in order to signal for RBF, I have to set that sequence number to be less than FFFFFFE. So I've set the sequence number here. I want to make sure I have the correct transaction ID and index. And then my output is going to be the recipient, which in this case was who? Base 58?
No, well,
did it go to you?
There were two, but it ended up coming to me. I'm actually checking my wallet now to see it's synchronizing.
Oh, cool. So it went to super. So in this case, the recipient is going to be super. And then I am going to sign the transaction using the private key, but not using the master private key, right? I'm using the private key at the derived path of this particular address. If I use the master private key, it's not going to work. Any questions about any of that? Okay, so it's going to return a PSBT in hex, which is just the raw hex transaction. And we're going to send that directly to Adam back. And then he is going to propagate that across the network.
Nice guy.
Yeah.
Let's have a lot of free time to do that.
He's manually runs around to all the nodes. And it's like, here's one for you, here's one for you.
So this, when I send Adam back a address, he sends me back a JSON file that has a bunch of different objects inside of it, and one of them is called TXRefs. And this refers to all the transactions that are currently at that address and all the transactions that ever were at that address. So it presents me with an array. I loop through the array, and I look to see if the transaction or the UTXO has been spent. So if it's been spent, it's not spendable, and I can't spend it. But if it hasn't been spent, then I found one that I can spend, and I'm going to use that TXID in my game. How many of you have actually built HD wallets? So this is super easy, right?
No. I mean, that's easy, but H2O aren't.
Right.
Found it. I got the transaction.
You got it. Super got it.
Congratulations.
Yay.
It works.
So then at this point, I just broadcast the hex transaction to Blockstream, and they send me back a TX ID.
So, say that again. Can you say again? So,
Right. So after I've built the raw hex transaction, then I just send the hex. In this case, I'm just broadcasting it to Blockstream's API. I could send it to my own node, but I'm trusting out of back with my transaction. And then they're gonna, if they successfully receive it and there's no problem, they're gonna send me back a response, and the response is gonna be a TX ID or a hash of the transaction. So I learned a lot in doing this, because a lot of the time when I would try to send them a transaction, I would get an error back. And often the error would be because I wasn't RBFing by a high enough fee. So I was getting a lot of problems, and I didn't actually know why my transactions weren't being received. One of the problems was if I'm sending to a different type of address, the fee can increase. So for example, legacy addresses take up a little more space than SegWit addresses, and within SegWit you have pay to public key hashes and also pay to script hashes. And pay to script hashes are like 12 bytes more. So there's a couple of things that I kind of got tripped up in doing. And yeah, for the most part, I highly would recommend playing with Bitcoin.js. How many of you now want to learn Bitcoin.js? It's fun, and you can make fun stuff like this, and you know, it's definitely not going to be like the best way of having the most secure and the most private wallet in the world, but I think for something like this, it makes all kinds of sense. And then if you want to iterate on your project, you can build it using APIs, and then you can rebuild it again using your own node and using some additional layers of privacy.
If you're running mempool.space on your embassy or something like that, you can have it talk to that instead of talking to Blockstream.
Yep, exactly.
And it would be just as private and just as secure because it is using your own node then.
But we all trust out of back, right?
We all trust.
I do dump mine all the time, man.
We're also sending. I'm also sending to this random block cipher API. God knows who that is. Don't even know. I'm also pinging mempool spaces API. So what I also do is I check to see what the fee rate is to get into the next block. So if I open another file here.
Yeah, I'm curious where are you calculating the fee? I think maybe I missed that.
Yeah, that's in a different file, so I'm pulling that up. So in this file, I've got some like HTML in here too.
Because mempool.space has a recommended fee API, I think.
Yeah, it does. Okay, so what I'm doing is I build a transaction and I figure out how large the transaction is in virtual bytes. And then I ask mempool what their fee estimate is. And they have different options they can return to you: medium priority, low priority, minimum, so that it even makes its way to the mempool at all, and fast. And so I get the fast fee rate, and I save that because if the game were to end very quickly, which has happened, I want to make sure we get to the next block. So I'm always going to calculate my base fee based on the fastest fee rate. So what I'm doing, I'm getting the fastest fee rate, and I'm getting the size in V bytes, and I'm just saying multiply the fast fee rate by the V bytes, and then I hacked in a few extra stats here. Total hack because I got lazy, because sometimes if I'm switching from pay-to-witness public key hash to pay-to-witness script hash, which is like you use for multi-sig with SegWit, you have these 12 extra bytes, and that was pissing me off, so I just hard-coded some extra bytes in here.
How much are those? What value do you use?
Well, at first I was using 5 randomly, because if you have a legacy address starting with a 1, I was getting a 3 extra byte problem that was actually preventing my game from working at all.
But now you use 15?
Now I'm using more, yeah, because Like I could recalculate the size of the transaction every time, but I just got lazy. I just hard coded in like a few extra stats.
It's still better than what most wallets do. They just say 500 and call it a day.
So that virtual size, you're saying that's like for the first transaction, but you're not getting the size of the...
I don't keep re-getting the size.
Right.
I could, I just got lazy and hard coded in a constant.
It was also like the day before it was time to present. So.
Basically, you guys know JC Crown? We were playing online, he gave me a legacy address, and we were playing the game, and the game broke. And I was like, why is it not working? And it was like, I was 3 sats short for the minimum threshold to RBF the replacement transaction. So I was like, okay, I just put in a hard-coded constant of some extra padding. But tx.virtual size is a really helpful method that's included in Bitcoin.js natively. So that'll just tell you what this virtual size is, which first we were trying to calculate and be like, okay, like this part is SegWit and this part isn't, and this part counts for this many bytes, and it was just like too much. So I figured out I could use this. This is my first time using Bitcoin.js, so I'm like learning what methods. There's not really any documentation that I can find, so we're just kind of winging it.
There's a really good Bitcoin.js tutorial that he did at TabConf, and
cool.
that's on his GitHub.
Nice. Yeah, so it's actually super simple, especially once you've done it once. And then once you've done it once, you can build all kinds of fun stuff. Any questions about the code? Seems pretty simple, right?
How custom is the ball physics? Is it just some lines of code here, or does it call on a library?
Yeah, so the ball, so the video game part is like totally interchangeable. So I just like found some open source like JavaScript client side stuff, which by the way, if anyone has like another JavaScript game, we can easily port the different game in here. So we can have any kind of game, and then I can just update it to call my functions. So the ball game just uses like a HTML5 canvas, if you're familiar with that. And it just has, it's not like a ton of complexity here. It's just like
XY coordinates.
some XY coordinates and some constants that we're using to like bounce stuff off each other. If you notice, like the players didn't collide. I don't know if you guys noticed that.
They passed through each other? They did, yeah, because you could chase.
So I can make the players collide doing this, but it makes the game a little harder.
Oh, yeah.
So I'd be curious to see if anyone wants to guinea pig test that version of the game and see if we like it better.
And what if you made the ball travel along SecP256K1 instead of a straight line?
Right, so if the players are colliding, can you lock another player in a transaction pin?
We can try. If anyone wants to try. I mean,
we did try. When we implemented this yesterday, we tried pinning each other and couldn't do it.
Yeah, so the
Just add another player to one corner.
Are there any game devs in the room? Just one. I'm not a game dev myself, so this is not my forte.
I'm proud of you because Dusty was like, "Oh, you're doing this wrong," and we tried it and it worked. He was like, "Oh, well, never mind then."
Yeah, we kind of like hacked it through some of the modifications to the game. But that's pretty much it. We'll see if anyone has any questions.
Thank you, Dusty.